Morning.
Morning.
All right. Okay, so we're going to go through and do some math. Okay, theory, bounds on integral. If a function is continuous on a closed interval from a to b, and m, lower m, and capital M denote the absolute minimum and absolute maximum. So now, listen, this is one of those, what was a stupid word they used for it? Sup? Yeah, sup. Yeah, so for the maximum and minimum actually had like a different word for it. No, I just took this stupid class too. Anyway, it's referring to over a certain range. Okay, so what's the probability of a maximum and a minimum? And so it's got to be between certain things. So if you look, I'm taking the integral, right? The minimum, okay, and it's going to be less than, equal to, this one right here, which is my function of my integral, and then I have my maximum. Soup. Where the minimum would be like we have here. From A to B, the minimum is only from this piece right here. So it's all this, okay? And the maximum would be all the way to the top. If you notice, these are my rectangles of this, right? Yeah? Okay, so it's in this right here, it's my min over that interval. The minimum. That means it is the lowest point on that interval, right? So, on a closed interval, if my lowest point is 5 and the highest point is an 8, okay? So, what I would do is it would be my right here, since let's say it's this spot right here. Okay, it would be f of a, if that's my lowest point right there, times, okay, from a to b, so it's b minus a. So what do we normally refer to this thing as? Delta x, right? So how far is it from b to a, right? That's what I'm looking for. So it would be my delta x. And so this would be my lowest point here. Let's call this piece right here a C for the sake of. So for the max, so this is my lowercase m, and the max, capital M, would be f of C, right? So it's going to be f of C, since that's the highest point, f of C times delta x. Does that make sense? From B to A is going to give me how far those are apart. Yes? Dulce? You okay? You're zoning out on me.
Mm-hmm.
Go ahead, Odie.
What would your delta x be in that situation?
Just right here, just B minus A. So we're just finding out how far it is from B to A. Yeah, so if this starts off at 0, if it would be at 0, it would just be B, right? So it would be going all the way to B, so my delta x would just be B, right? Okay, but since it's not starting at B, not starting at 0, it rarely actually does start at 0. Okay, so we need to actually, the top minus the bottom is going to give me the whole thing. That make sense now? Okay, so inf, that's what it is, inf, sup and inf. Okay, maximum is sup, is the suprema or something like that, and inf is the other one. I'm telling you, I had a foreign guy actually teaching the class, and so, you know what? I love you, Filippo. You're great. All right. So anyway, so he's Italian, so he's just good. He's just this. I'm like, come on, dude, seriously. But yes, the very thick Italian accent. Okay, he came to this country in like his 20s or something like that. So yes, he has a full-on Italian accent, and yes. doesn't talk with his hands though, so I didn't understand what he's saying.
How would you communicate math through hands? I don't know, that's weird. Like, how would you go around like communicating math?
Like sentences.
Yeah. Oh, no.
Forget about it. See, you don't know what he's saying unless you see the hands for that, right? Anyway, all right, okay. All right. So Filippo might actually be watching my videos right now anyway. All right, so find an upper bound, lower bound for the area A under the graph of blah from blah blah blah. All right, so it's a closed interval, isn't it? Sine is a wave.
Yeah.
Okay, sine is a wave. There's a closed interval, right? Closed interval from there to there. It is continuous. Yes.
Yes.
Okay, what is my lowest point between 0 and pi for sine? Wrong.
0.
0. So,
Wait, what is your least? What was the question?
Just the
are tacos good?
one.
Yes.
Yes, see? The answer is yes.
Okay.
Okay, so, from on sine, my function sine, right? The function sine from 0 to pi, what's my lowest point?
Oh.
It's 0, isn't it?
0.
Okay, it's 0. Yeah? So it doesn't go into the negatives until after pi, right? Okay, so my lowest point, so my little m is going to be, it's going to be f of what?
Pi.
0 or pi, right? Because they're both going to be the same, right?
Are there?
Are they?
Because it's a wave, right?
What's the lowest point on both sides?
Oh, yeah.
Yeah. So both sides. So f of 0 is going to be my lowest right there, times,
Pi, because your A is 0.
yes, there we go. So b minus a, so it's going to be pi. And then my max is going to be,
Pi halves.
so f of pi over 2 times delta x, which is pi. All right, so I know that if I were to do this, okay, I have left bound, right bound, kind of like we have right here, left and right, and then the function is somewhere in between, right? Okay, yeah, somewhere between there and there. All right, so the maximum area of this is going to be, what is sine at pi over 2? 1 times pi.
3.
Pi.
Pi.
1 times pi is pi, right?
Yes.
Okay, good. All right, 0. So f of 0, so sine at 0 was 0 times pi.
0.
So that my whole thing is set up that it's going to be, my interval is going to be between there and there, right? Yeah, so that's the lowest point that it could be. This is the highest point that it could be. So that my integral's got to be between somewhere in between there. Okay, why are you shaking your head at me?
Like, wait, it already had 0 to pi, so it's like the same information.
It's an easy problem just so we can understand the concept. Yeah? Yeah, but it's, yeah, because sine is a wave, and this one's pretty easy, right? So we're going to get into other functions that aren't regular, just sine waves. Okay, we're going to get stuff that is off of that. All right, so from here, then let's do the integral then from 0 to pi of sine x dx would give me, what's the integration of sine?
Negative cosine.
Negative cosine x, right? From 0 to pi. All right, what is cosine at pi?
Negative 1.
Negative 1. Negative 1, and I also have right here. Negative 1, and I have an opposite right there, right?
1.
Which is just going to be 1. So that's going to be 1, right? So it's going to be a 1 minus the bottom. What is cosine at 0?
1.
So it's going to be 1, right? Cosine at 0 is 1. So this is going to make it negative 1, right? So my total area for the integral is going to be 2. So my total area of the integral. So let's take a look. Is this going to be true? So is my little m less than equal to my capital F is less than equal to capital M? Is that true? Yeah, it is. Because right here we got 0. Here we get 2. And here we get pi. You guys need to try and remember, what's pi? 3 point something, right? Yeah.
Wait.
Yeah. Yeah, go ahead.
How can it be, oh, never mind, I dropped.
Does that make sense now?
Yeah.
Basically? Are you okay with that? Okay. So, suppose a function that is continuous and non-negative on a closed interval from a to b, blah, that figure, okay, suggests that the area in the graph from a to b is equal to the area of some rectangle with a to b and the height of f of u for some choice or choices of u in the interval from a to b. So, if you notice, I have a little bit above my function, and I have a little bit below my function, right? So, if this is my function right here, I have a little bit above and a little bit below. So, these parts are above, this part is below, but it should be equal to it at some point, okay, over that same interval. Over that same interval, it's going to be equal somewhere. Okay, so we're going to get f of u. So this is equal to some f of u over b minus a. Remember, what was the b minus a? What do we call that? Delta x, right? That's my delta x. And then f of u is some point on the function, but we don't know u.
But I know you.
I know you too. All right, see? Thank you. All right, function is f continuous on a closed interval a to b. There is a real number u from a is less than or equal to u or less than or equal to b, which we get their function right here. Okay, let a function that is continuous on a closed interval, it is function f constant f, say f of x is equal to k on a to b, then, okay, we're eventually just trying to figure out what this is going to end up being. Because I want to figure out where that k is. Find numbers, use guarantee the mean value theorem for integrals from there to there. Okay. I know it's supposed to be equal to something value, right? So I know that my integral from 2 to 6 x squared dx has to equal to some value, right? Some value k, or, yeah, right? Yes? Okay, and it's going to be b minus a, which is going to be,
What?
there we go.
I see.
So, what do you think I'm going to do with this? Solve for it, and then solve for k, right? Okay. So, I know that f of u is equal to my k value. That looks like a bad language. All right, there we go. All right. Okay, integrate. Integrate. So this is going to be x cubed from 2 to 6, right? X cubed over 3 from 2 to 6. Okay, and that's going to be equal to k, 4k? Yeah, there we go. All right, so top minus bottom.
Actually, where'd you get 4?
4?
Oh, delta.
Yes, delta x. So 6 minus 2 is going to give me 4. Right, Watcher?
Yeah.
Okay, good. Like I said, I'm not very good at basic math. All right, so let's go ahead. So let me see. 6 to the third power, is that 216? 216 divided by 3?
Someone not there.
That
I
works.
thought it was 108.
It's 108?
Wait, wait, wait.
Someone not there.
Hold up, divided by 3.
Yeah.
72.
72? All right, so 72 minus, okay, to the third is going to be 8 over 3. Yes, 8 over 3 is equal to 4k, right? And if I want to go ahead and do that, so let's put it back over 3. That would make it, so 216 minus 8 over 3 equals 4k. That's a k. Wow, that's an ugly K. Can't fix that one. All right, so
Why is that for X?
why is that 4F?
No, X.
I know. See, they're ugly K's. There we go.
Yay.
Yay! All right. Okay, so that means that's gonna give me 2 over 3. You mean 208 over 12? Yes, 208 over 12. Yep. So K is equal to 208 over 12, which I know I could reduce it, so it should be 104 over 6, which is 54 over 3. K equals 54 over 3.
Nice. I did that.
Almost. That's K.
F.
Now, FU equals K,
Okay.
right?
So FU equals 5.
Okay, so what is my F of FU?
FU.
Okay, so my function, what's my function?
X
My
squared.
brain's shutting.
So I have x squared
So bad.
Equals
I didn't say anything.
has to be equal to 54 over 3. And it's going to go x equals plus or minus square root of 54 over 3. Now, is the negative inside my interval? Say no. No. The negative is not inside my interval, is it? What's my interval?
From 2 to 6.
2 to 6. So from 2 to 6. Now, someone please math this for me. What is the square root of 54 over 3?
3 divided by 4, which is 3.
Oh, yeah. Wait, hold on. What's 54 divided by 3? That does go in evenly, doesn't it?
No.
Mm.
No,
Yes,
wait.
Yeah, it does.
It does.
It does, but
18?
Oh, yeah, it does, because 5 plus 4 is 9.
Yeah, square root of 18, right?
yeah, but
5 plus 4 is 9.
Yeah.
So you could say no.
Yeah.
Yeah. Yeah, that's how you can figure it out. So 5 plus 4 is 9. So is 9 divisible by 3?
Yes.
Yes. Then it does divide evenly. So x equals the positive square root of 18, which we said is a boot.
You got K wrong.
No! Why'd I get k wrong?
Like 208 divided by 12 is 52 over 3.
Dang, that's tough.
52?
Yeah.
but yes. Or yeah.
52. Thank you. I was like, see? Thank you, Watro. And so it was k 52 over 3. So x squared is equal to 52 over 3. So x equals plus or minus the square root of 52 over 3. And so that's 7. That doesn't work out. So x is going to be the positive square root of 52 over 3, which is a boot. What is it a boot? Good catch, Watcher. Ah, there you go.
What is that?
Oh, chocolate.
You got chocolate. He caught my mistake.
And the chocolate.
4.163.
Okay, 4.163. Is that in my interval? It is in my interval. So I now know what my K value is going to be, right? So I know my K and I know my F of U, right? So when I plug in this number here, so my U is equal to the square root of 52 over 3. So that is where, when I draw my, where's my little graph? Right here. When I draw my thing right here, right? So because of the way that this curve is, where my U is, it's on my function. And so if I box it off from there, that is going to be equal to the area of the integral. Are you okay?
Yeah. That makes sense.
Okay, so there's a lot of work into this. So I want to make sure you guys, understand and fully,
Okay, I have a question.
yeah, go ahead.
Okay, so if you find the area of the box, then that will be equal to the area under the line?
Yeah, area of the box. Okay, all blue. So area of the box, which is here, is equal to the area of the integral. Okay, because integral is area under the curve. Okay, and so in this case, it is going to be equal to my from A to B of f of x dx. It's equal to that because when I took the area of under the red line, right, it's equal to the same thing. They're both going to be exactly the same. Okay? So this goes with the mean value. I think that's it for that one. Okay? All right, so I'm going to pick up the rest of this tomorrow. We got like 10 minutes left. Like, share, and subscribe.